In this video, we're going to look at trig integrals where you have products of powers of tangent and secant, and there's basically two cases that we'll look at in this class. The first one is where you have an even power of secant. And so the trick in this case, again, we're going to try to use an identity to rewrite this and then use a u substitution. So the trick is going to be, we're going to think of our u as tangent, so we know our du is then going to be secant squared. So we're going to start by pulling out a secant squared. And then the goal is this is going to become our du. So then we're going to need to change this to tangent of x using an identity. And then we'll be able to do a u substitution. So I'll show you how. So notice this secant term we can rewrite as a secant squared inside here, and then it's going to be to the power n minus 1. And then I'm still left with my du here. And then I'm going to use a trig identity to be able to rewrite this. We know secant squared is 1 plus tangent squared. And now we see this is all set up to be able to do our u substitution. Okay, so that means I'm now going to have u to the m, and then 1 plus u squared to the n minus 1, and then du. And basically to do this, you're going to need to FOIL this whole quantity out here, multiply everything through, and then just integrate term by term. Okay, and then of course you'll switch everything to be back in terms of x once you're done with the integral. So let's look at one more case, and then we'll do a couple real examples, but I just wanted to outline the main strategy. Another common case with powers of secant and tangent is if tangent is raised to an odd power. And in this case, what we're going to do is ultimately a u substitution where we want to let secant be u. And so if you recall, if you let secant be u, then du is going to be secant x tangent x. So that's what we're going to want to pull out first, is pull out a secant and a tangent. So I'm just going to be left with secant to the m minus 1 now, and then just tangent to the 2n, but then I will have a secant x tangent x. Okay, and again, that's so that this will become my du, and so I'm going to want to rewrite this in terms of secant now using my identities. So notice this is the same as tangent squared, all raised to the power n. And then here's where we can use the identity, because we know that tangent squared is the same as secant squared of x minus 1. And now we have everything ready for our u sub. So let's just make this a little bit smaller so we can put the u sub in here. So now we'll have u to the m minus 1 times u squared minus 1 to the n, and then here's du. So again, you're just going to need to expand this out, and then you'll integrate term by term, and then put everything back in terms of x at the end. So let's try this now with a concrete example. Okay, so given this integral and what we just showed, see if you can put this on pause, take a second, and see if you can evaluate it. Okay, so since we have an even power of secant, we're going to let our substitution be u is tangent, which means we're going to want to pull out a secant squared. And then we're going to want to change this to be in terms of tangent so we can do our full substitution. This is going to be the same as secant squared, quantity squared, but we know that secant squared is 1 plus tangent squared. So I'm going to have that quantity squared. And then I'm still left with the secant squared x. And now I can turn everything to be in terms of u. So now I have u to the 4th times 1 plus the quantity, or 1 plus u squared, all squared, and then du. So now if I expand all of this out, I'm going to be left with the integral of u to the 4th plus 2u to the 6th plus u to the 8th. And now just integrating term by term. And then lastly, we'll put everything back in terms of x And that leaves us with this for our final answer.